All right, well, welcome to lesson number 2. So in lesson number 1, we talked about um, average rate of change and instantaneous rate of change. And if you remember, the average rate of change is the slope of the secant line, which is basically your slope formula, right? y2 minus y1 over x2 minus x1. And we looked at just some examples graphically. So we said something like, well, if this was your first point, this being your x1, and this is your y1, and then maybe this is your second point. So this would be x2, and this is y2. Then the average rate of change can be found by looking at the distance or the slope between those 2 points. Your instantaneous rate of change is found when these 2 points, so let's say that you were trying to find the instantaneous rate of change of that point. So we would take 2 points close to that point and we would find the slope. Well, the closer those points get, the more accurate that estimate of the instantaneous rate of change. So this is actually a concept that we call limits, okay? So today we're going to actually talk about what a limit is. Oh, I'm sorry, I didn't finish this. Instantaneous rate of change is the slope of your tangent line. Let me just finish that thought there, I'm sorry. So as we get closer and closer to this actual point, right, we take our 2 points and we keep moving our 2 points so that they get closer, right? Well, if they get close enough, that secant line becomes a tangent line. So what we're actually doing when we're finding the instantaneous rate of change is we're finding the slope of the tangent line. Okay, today we're actually going to look at what limits are. So the notation for a limit looks like this, right? The limit as x approaches a of f of x equals L. That's actually how we notate a limit, okay? So what does this actually mean? Well, let's look at an example graphically. Okay, so I'm going to call this point A, okay? So the limit as x, right? This is x. So as x approaches A, so right, let's just say that x starts out there, okay? Well, what's happening with f of x? Now remember, f of x refers to the y value. What's happening to the y value? Okay, so let's just put some numbers here. 1, 2, 3, 4, 5, 6. Okay, so right now, if this is where my x is, then f of x is 3, right? But let's move our x closer. Let's call that x1. This is x2, right? So here, looks like maybe f of x is 4. So the limit as x is approaching, right, what's happening to the y. So let's keep moving our x a little closer. Let's call this x3. So there's my y value, and it's just shy of 5, maybe 4.75, right? So what we mean by limit, what's happening as the x is getting closer and closer to this value here, which is where x equals a. As the x is getting closer and closer to a, what's happening to y? Well, in this case, y is approaching 5. So we would say the limit as x approaches a of f of x is equal to 5. So this number here, the actual value of the limit is actually the number that the function is approaching. Okay, so let's look at a couple examples, and I think it'll be a little more clear as we do that. Okay, so I'm just going to sketch a couple graphs here. Let's see, let's make it a little bit more interesting. Let's do this. Okay, so that'll be our graph, and we've got right, 1, 2, 3, 4, 5, and here we'll go 1, 2, 3, 4, 5, 6. Okay, so I want to know, I'm going to call this f of x, all right? What is the limit as x approaches 5 of f of x? Okay, so let's see what's actually happening. Here's x equals 5. Okay, there's x equals 5. And here's the y value that goes with that, right? So what's actually happening? Well, as x approaches 5, what's happening with y? These are my y values, right? What is y doing? Y is approaching this value right here, which is 4. Okay, so now here's the interesting thing, right? Let me just see if I can. Oops, I want to leave that there, sorry. Leave that 4 there, all right? Let me see if I can erase some of this stuff. Okay. Now, here's the thing. Let's pretend that on this curve that's an open circle. So in other words, this function is undefined there, right? So f of 5 in this particular example is undefined. Let's just pretend that that's the function that we're looking at. So in that case, what would the limit as x approaches 5 be? The limit as x approaches 5 of f of x. What would that be? Well, let's look at what's happening, right? As x approaches 5, what is f of x doing, right? What is f of x? This is f of x, right? The y value. What's it doing? What is it approaching? That's the key. What's it approaching? Well, it is still approaching 4. Although f of 5 is undefined here, the limit, what we're actually approaching, is still 4. So that's kind of a different, something that you're not used to thinking about, right? The function itself could be undefined at 5, but the limit still exists. It's still approaching. It doesn't actually ever equal that, but it's approaching that. Okay. So here's another example. I know this is kind of something a lot of people, it bothers people. because you're kind of like, well, how can that be? I can't have something approaching. It just bothers people. I know it does, but that's okay. We'll get used to it, right? Let's look at another function. Um, let's look. This one's going to be similar, right? Here I've got a point where it's undefined. There, right? Okay. So let's look at this function. What's happening here? What is happening here? So let's say 1, 2, 3, 4. So that's 4. And we're going to do 1, 2, 3, 4, 5. Okay. So I want to know the limit as x approaches 4 of f of x, right? This is f of x. What's happening as x actually approaches 4? So here's x, right? X is down here, right? As it's getting closer to 4, what's happening to the y value? So as it's getting closer to 4, what's happening to my y value? Well, it looks like it's approaching 3, doesn't it? Does it look like it's approaching 3? Well, let me ask you something. What is this? What does this mean? Right? What does f of 4 actually equal? So when x equals 4, what does y actually equal? Well, according to this graph, when x equals 4, y equals 5. So here we see a case where, right, when x equals 4, y is actually equal to 5, right? However, the limit as x approaches 4 is 3. So that means that the limit does not have to be the same thing as the value at that point. Okay, let that sink in a minute. The limit, the number that we are approaching, right? The number that we are approaching, right? This is it's clearly approaching 3. That does not have to be the same thing as the value at that point, right? This is this is a jump. This is actually called a jump discontinuity. We'll talk a little bit more about that in a little while in another video, right? This particular function is discontinuous and it jumps in its discontinuity. We talked about this early in the pre-calculus class last year, right? So we've got this limit, it's approaching this value, but then when it gets to 4, it actually jumps up to this number. But the limit as it's approaching that value equals 3. Okay. Okay. Here's another example. Okay. So let's look at this one. 1, 2, 3, 4. And we'll go 1, 2, 3, 4. I know my lines. Let's make 4, 5. Okay. Okay. So if we look at the limit, again, we label this as f of x. The limit as x approaches 4 of f of x. What's happening as x approaches 4? Well, if we look here, what's happening to y? It looks like y is approaching 3. But then look over here, what's happening? Here, it's approaching 5. This is what we call, this is a discontinuity also, okay? This is when we have to look at what we call the left-hand limit and the right-hand limit. So if I look at the limit as x approaches 4 coming from the left, so we put a little minus sign up top there, right? This means the limit as x approaches 4 from the left, right? The limit as x approaches 4 from the left, right? If we look at that, say, okay, what's happening as we come from the left? Well, f of x is approaching 3. But then if we look at the limit as x approaches 4 from the right, and we use a little plus sign there of f of x, the limit as x approaches 4 from the right. So coming from this direction, what's it look like? Well, we're approaching 5. This is what we call one-sided limits. Okay? So in this example, we have the limit as x approaches 4 from the right equal to 5, the limit as x approaches 4 from the left of f of x equal to 3. Since these two limits are not the same, right? These two limits are not the same, then that means the limit as x approaches 4 does not exist, right? That stands for does not exist. Okay? Since these two are not equal, the limit from the right is not the same as the limit from the left, then the limit does not exist. Okay? By the way, what would f of 4 equal in this particular example? There it is right there. F of 4 would equal 3. Okay, let me give you another example graphically, and then we're going to look at some tables. Okay. Let's see here. Okay, that's the best I can do there. And we're going to go 1, 2, 3. Okay, so I want to know what f of 5 equals. I want to know the limit as x approaches 5 from the left of f of x. I want to know the limit as x approaches 5 from the right of f of x. And I want to know the limit as x approaches 5. Okay? All right, so let's look at this. F of 5. When x equals 5, what does y equal? Well, there's the point right there. So y would equal 3. So f of 5 is 3. Now let's look at the limit as x approaches 5 coming from the left. So as we come from the left, what is x or what is y doing? Y is approaching 4. The limit as x approaches 5 from the right. So as I come from the right, what is happening to y? Y is approaching 3. So what is the limit as x approaches 5 of f of x? It does not exist. Why does it not exist? Because these two are not equal. Okay, here's another example. I'm going to use the same graph just to make it quicker. Okay. Okay, so let's draw one that looks like this. Oops. Let's do okay. So let's answer the same questions. What is the value of f of 5? Okay, that's going to be 4. When x equals 5, y equals 4, right here. What is the limit as x approaches 5 from the left? So what's happening as we approach 5 from the left? We get 3. How about approaching 5 from the right? We also get 3. So what is the limit as x approaches 5? Okay. These are equal. They're both the same. From the left and the right, we're approaching the same value. So that means this is also 3. Even though these are different, right? We don't have to equal the value there, but it has to be the same as the limit. Okay, another way that we can look at limits is by looking at a table of values. So let's look at the function f of x equals let's see, x cubed minus 8 over 4 times x minus 2. Okay, so first off, what is f of 2? Well, f of 2 is going to be undefined, right? Because if I put a 2 in here, it's undefined in the denominator. I'm going to get a 0 there, okay? So let's now look at the limit as x approaches 2 from the left. And let's look at the limit as x approaches 2 from the right. And let's see what's going on. Okay, so I put it in my calculator. Right here, if I graph it. And by the way, if you look at the graph, it's not clear that it's undefined at x equals 2. Okay, and if you remember, graphically speaking, remember how the graphing calculator works, right? It plots points and then it connects those points. So I think I did this with you last year. I showed you by looking at the graph, the dots, right? Oops, that didn't help at all, did it? Okay, let me try. I'm not sure if it's going to help me here. Maybe it won't. There we go. Okay. So the way the graphing calculator works is it plots points and then it connects those points. So you can't tell that it's undefined at x equals 2. The only way you can tell that, I can fix this again. Okay, the only way you can tell that is by looking at the table of values. Okay, we can see at x equals 2, we get an error. Okay, so that tells us. But what I did is I went and I created a table. Okay, so this list 1, right? I'm approaching 2 from the left, right? I start at 2's right in here, right between these two numbers. From the left, real close to 2 is 1.9999. And then we have 1.999, 1.99, 1.9, right? So if I were looking at a number line, right, here's 2, right? So real close to that, I've got 1.9999, right? 1.999, 1.99, right? And I'm getting further and further away, right? So if I want to get real close to this point x equals 2, I'm looking at 1.9999, all right? Well, what's happening with the y values? I already plugged the formula in here. So we've got 2.8525, 2.985, 2.9985, 2.9999. What's the y getting close to? It looks like 3, right? And then if I go the other direction, right? So getting close on this side, right? Let's start out here, 2.1, 2.01, 2.001, 2.0001. See, I'm getting closer and closer and closer to 2 from the right-hand side. So if I look at my table, right, here's a 2.1, I'm getting closer and closer to 2 from the right. What's my y value doing? It's getting closer and closer to 3. So the limit as x approaches 2 from the left, right, is approaching 3. Right here I am at 2.9999. So the limit as x approaches 2 from the left is 3. The limit as x approaches 2 from the right, look what's happening. It's also 3. So although the function is undefined at x equals 2, the limit is defined. So what is the limit as x approaches 2? Well, that limit is going to be 3. Okay, so we look at that table of values and we can see what's going on. Okay, let's look at another just from the table of values. Okay, so I'm just going to say here's f of x, right? And I want to figure out the limit as x, oops, sorry about that. Let me rewrite this. Let's find the limit as x approaches 1 from the left. Okay, and then we're going to find the limit as x approaches 1 from the right. Okay, and then we're going to find the limit as x approaches 1. Okay, and I'm going to do this all from a table. I don't know why I'm bothering to get so fancy. That's silly, but oh well. Okay, let's see. We're going to do 0.9. Okay, this is x, and this will be f of x. All right, 0.9. I'll do 0.99. And then we'll go 0.999, 0.9999. Okay. Remember, I'm trying to find the limit as x approaches 1. All right. And then, so we're going to say that this would have been the value. This would have been 1 right here, right? So then on the other side, let's go real close to 1, 1.0001. And then we'll go 1.001, and then 1.01, and 1.1. Okay, so this side over here, this would be coming from the right, and over here we're coming from the left. Okay, so what are my y values? Well, let's make this a 0.51316, and we'll say that this is 0.50126, and this is 0.5000125, and this is 0.5000125. Okay, and then over here, change colors again, on the right, this is going to be 0.49999, and this will be 0.49987. And here we get 0.4987, and then we get 0.4887. Okay, what is the limit as x approaches 1 from the left? As we approach 1 from the left, well, it's clearly getting closer and closer to 0.5. How about the limit as x approaches 1 from the right? So we're going that way. Well, we're clearly, again, approaching 0.5. What is the limit as x approaches 1 without paying attention to which direction I'm coming from? 0.5. Okay, so remember, in order for the limit as x approaches 1 of f of x to exist, it must be equal to the limit as x approaches 1 from the right and equal to the limit as x approaches 1 from the left. They must all be equal in order for the limit to exist. Okay, we can look at that from a table or we can look at it graphically. Okay, all right, we're going to stop there. In the description at the bottom of this video or below this video, right, in the description section, there is a link to a worksheet. I would like you to complete that worksheet. Now, when you open it, do not open it in Google. So it's going to give you an option to Ogle. It's going to give you an option to Ogle. It's it's going to give you an option to open in Google Docs. Do not do that because Google Docs messes up all the symbols. So when you open it, you're going to either copy it down on a piece of paper or uh, write on the PDF document in your Notability. But I don't know if you'll have your iPad, so you may have to just copy it down on a piece of paper. Okay, but again, do not open it in Google Docs. Okay, look forward to the next video.